Good day, class. In this lesson, we will study factoring trinomials with a leading coefficient of 1. First, I'd like for you to be able to categorize the different types of polynomials that you might see in order to help you determine how to factor them. You should always look for a greatest common factor. Whenever you're looking to factor polynomials, be sure to look to see if there are any terms that can be pulled out initially that will help simplify the problem. Be sure to review the greatest common factor lesson if you have not done so already. Also, you'll look for the number of terms that are in that polynomial. If you have 4 terms, be sure to give grouping a try. Remember, there is also a lesson concerning factoring specific to factoring by grouping. If you have 4 terms, grouping is very likely the best possibility. We also have lessons on special products, the difference of squares, which you can recognize if you have a difference, 2 different signs in your polynomial terms, and if both the first term and the last term are perfect squares. Also, you can recognize binomials squared. If you have a first term that's a perfect square, a last term that's a perfect square, and the term in the middle that has been doubled and multiplied by the first term and the last term. Remember, there is a lesson specific to each of these. Be sure to also look for the sum and difference of squares. If you have a sum and difference of cubes, if you have a perfect cube in the first term, a perfect cube in the last term, and it's either the same signs or different signs. Be sure to review these lessons if necessary. For everything else, we will expect to factor trinomials, which is what we'll cover in this lesson today. Remember, when we're factoring trinomials, we do want to initially focus on that leading coefficient. Is that leading coefficient equal to 1, such as in this example, where the very first term has a value of 1, or a leading coefficient of greater than 1 or less than 1, where the very first term is not equal to 1. Moving right along, we also want to know what is factoring. Factoring by definition will be the opposite of multiplying. So notice in this example, we have 2 binomials that are being multiplied because they're sitting right next to each other inside of a parentheses. So in order to multiply these binomials, we've learned how to use FOIL that will reveal our new trinomial result. Now, in order to factor, it's essentially going back the other way, or reversing what we've done and revealing the 2 terms, in this case, that have been multiplied to make up the new polynomial. This is the opposite of factoring. This is the opposite of multiplying, which we could call unmultiplying, but it's a little bit non-technical, so we'll go with factoring. We also want to keep in mind that when we're factoring trinomials, polynomials with 3 terms, we anticipate binomial factors being our result in many cases. Not in all, but in many cases we will have binomial factors. So let's talk about factors. Here's a term 14, and it has factors of 2 and 7. Here's a term 9. It has factors of 3 times 3. 2 numbers that have been multiplied to make 9 would be 3 times 3. We also have the number 17. As you might know already, this number is prime. The only numbers that we can multiply are 17 and 1 to get 17. That's okay also. You'll see this scenario take place when we're factoring trinomials. Here's another example. We have terms here, 20x plus 10, and 2 numbers that have been multiplied are 10 and x plus 1. Those are the factors of 2x plus 10, 20x plus 10, because they've been multiplied together to generate 20x plus 10. Therefore, if we have a trinomial, which is a polynomial with 3 terms, it most likely has two binomial factors, or two terms that have been multiplied by one another, that generate the trinomial. You will learn to do that today. Here's our first example. We see that we have a trinomial because we have three terms. Our first term being x squared, our second term being 5x, and our last term being 4. We also see that the leading coefficient is our understood 1. Therefore, it fits the mold of what we're talking about today. So here are the steps to resolve it. If we want to determine the two numbers that have been multiplied to help identify those binomial factors, then we'll first identify the possible factors of our last term. That is a very important step, and it must take place. The possible factors of 4 are 4 times 1 and 2 times 2. Those are the only numbers that can be multiplied to make 4. Also, we must identify among this set the only numbers that can add or subtract to make 5. Since 2 and 2, no possible way can make 5, whether we add them or subtract them, then the only possibilities are 4 and 1, because if we add 4 and 1, we can get 5. Our next step is to split up that x squared. So we're going to generate our binomial factors. We're setting up, getting ready to lay out those binomial factors. We're going to split our x's across each set of parentheses. Then we'll also split our factors of 4 and 1 across the set of parentheses. Now we simply need to determine which types of integers we need to go with in order to generate 5 from the numbers 4 and 1. The only possible way we can generate 5 from 4 and 1 is a positive 1 and a positive 4. Therefore, our solution for identifying two factors that can be multiplied that make up x squared plus 5x plus 4 could be the factor of x plus 1 times x plus 4. Now, it's very possible that I could have made an error, so it's important to be able to double check my work. Therefore, I'm going to multiply x times x times 4. Remember the FOIL method? 1 times x and 4 times 1. If this process gets me back to where I started from, which I see that it does since the 4 that I can combine like terms, then I have my... Let's look at another example. We're given 24 minus 11x plus x squared. I see that I have a trinomial. There is no greatest common factor that I can pull out of this. It is not a grouping problem because it only has 3 terms. It is not a special product such as difference of perfect squares or perfect cubes, and it's not a binomial square. Therefore, I know it must be simply a trinomial that I need to factor. However, we must be very cautious about keeping our terms in the correct order, alphabetical and numerical order, as we've talked about in these lessons. So be sure to change the order to an appropriate x squared minus 11x plus 24. Now I'm looking for the possible factors of my final term. My final term is 24. The only possible factors of 24 are 24 and 1, 6 times 4, 8 times 3, or 12 times 2. That's a lot of factors, especially compared to our last example. However, we're only going to deal with factors that can also add or subtract to make negative 11. The only possible factors of 24 that can add and subtract to make a negative 11 would be 8 and 3. Therefore, I'll set up my binomial factors. I'll split my x's across the parentheses. I'll also split those terms across the parentheses, those factors across the parentheses, and I'll identify that negative 8 and negative 3 are the only integers that can combine to make negative 11. Therefore, I'll presume that this is the correct solution. However, I do want to double check my work. Remember that factoring is the opposite of multiplying polynomials. So if I multiply these polynomials, I'll end up with x squared minus 8x minus 3x plus 24. If I combine like terms, I'm back to where I started with x squared minus 11x plus 24, which confirms that these are my binomial factors. Let's look at one last example. Once again, we want to identify the factors of the last term. The only possible factors of 2 are 2 and 1. Since in no possible way they can add or subtract to our middle coefficient, which is a positive 1, then I know that there's nothing more that can be done. That there are no numbers that multiply, just like the number 17, that can make this trinomial, other than the trinomial and 1, other than the number in itself.